everybody, and welcome to our next video, which is gonna be about how to sketch the graph of the exponential function we were talking during our last lesson. And I have chosen this function because it's kind of nice and a little bit easy, and you'll get some new information when you watch this video. The first thing I want to say, maybe you don't realize that this is exponential function because you don't see any number or base being powered to the x. But as you can see, our base in this function is this super special letter, which is letter E. And if you went through my homework I assigned to you, you probably found out that this letter E is like a number which value is approximately 2.7183. And it is irrational number, so it goes on and on forever without repeating any decimals. And this number has a special name, and it's called Euler's number. I'm not gonna talk about what is this number special, why is this number special, and so on and so forth, but for now it's enough if you realize that if you write like E, then it means you calculate with the Euler's number, which value is approximately 2.71 or 2.72. It depends how many decimal places you need for your calculation. So this is quick intro. And now, as you already know, I prefer, and I showed you that it's kind of clever idea because I will sketch the graph by using the transformations, and I will show you all the transformations which apply on this function. So let me simply rewrite my equation of the function. So I prefer to have unknown variables or unknowns as the first, so it would be negative e to the power of x plus 2 plus 3. And let's start with the first information. For all the functions and graphs I'll chart or sketch, I'll use different names and with the lower index of the name of the function, so that you will see what I really mean by transformation. So let's start with the function f1, which is of course our parent function, which in this case is defined by the equation e to the power of x. So basically, as you know, if e, or the base of our exponential function, is greater than 1, which in this case is, then the parent function graph is passing through the point, and I will denote always this point, and it is passing through the point with the coordinates 0 and 1. So this is our point. Why is it so? Because any base to the power of 0 is always equal to 1. And our asymptote is equal, or let me just write it easier way, is defined by the equation y equals 0. I was explaining why this is asymptote and why this function can never be like with the value 0. I'm not going to repeat it again. So let's sketch the graph of our parent function, which is f1 function. So basically we know that this is increasing really rapidly, and it should and it is going this way. So this is our parent function f1. Then if you have a look on our function here, the next transformation we have to apply, or the next one, or the second in the row, so it's gonna be like function let's say number 2, and it will transform my function so that I'll move or I increase each argument by number 2. So basically I can write that this function is defined like y equals f1x plus 2, of course. So this would lead to the equation y equals e to the power of x plus 2. We already know that if we add up any number to the argument of the function, it would transform or move our function 2 units to the left. We already explained why. That would mean that our point, let me put the coordinates here, which is 0 and 1, will have new coordinates, and its coordinates would be, as it is transformed or moved 2 units to the left, it's gonna be -2 and 1. So this is my new number, like anchor number or anchor point, I would say easily. And we already know that transformation to the left and to the right doesn't impact my asymptote, so my asymptote will remain with the equation y equals 0. Let me sketch the graph. So basically all the points are moved 2 points to the right, so to the left, so my function f2 will look like this. All the points are moved 2 points to the left, so I'm done here. The next transformation which will apply for my function f3, and then the function value will be defined as negative of the function f2. We already know that this negative number in front of my values would mean that all the y's become negative numbers, so it basically means my function will flip over the x-axis. But before we sketch the graph, let me just write the equation. So it means my function f3 is defined like -e to the power of x plus 2. So basically it means my function is flipped over the x-axis, what means for my anchor point, let's call it this way, that x value or x coordinate will remain the same, but what will change is my y coordinate, and it becomes negative. As you can see from this transformation or definition of this transformation, my number +1 will become -1, and we also know and can notice that our asymptote will not will not be transformed, because we are flipping our chart over the x-axis, so asymptote remains 0. Basically it means that my, let's say again, anchor point will come to this one with the coordinates -2, -1, okay, and we can simply sketch the graph again. Let's do it like symmetric with respect of the x-axis, and let me just be complete here. So these are the coordinates of my point. So the purple line is a graph of function f3 where we applied the transformation like for negative values of our function f2. And finally we have the last transformation, and let me come back to the black color. So it's gonna be function f, which will be defined like again with the equation y equals f3 of x plus 3. So we applied the last transformation, okay, which basically means that our equation is gonna be -e to the power of x plus 2 plus 3. Again, if you realize what this plus 3 means, it means that you add 3 units or number 3 to the y coordinates of the previous point. So it means our anchor point will have coordinates -2, and -1 plus 3 is -2. Okay, so here we just add up 3. So oh sorry, we add up 3, so it means not -2, but of course -2 and 2. Okay, so now it's correct. If I add up 3, this is it. But in this case our asymptote will change the position, and as it was before y equals 0, and we add up again 3 to the asymptote, then our asymptote equation will be y equals 3. Okay, the same thing applies here. So we started with the asymptote. Let me draw it with the red color as x-axis, and our new asymptote will be transformed to the line which is defined by the equation y equals 3. So my asymptote is passing now through the point y is being 3, and my point -2, -1 will be transformed to point -2 and 2, and nothing changes. So my function should look like this, and this is my function defined by the equation y equals 3 minus e to the power of x plus 2. Okay, so this is it. Let me just summarize what we did. So we started with the parent function, and our parent function is increasing and passing through point 0, 1, and with the respect of the asymptote y equals 0, which is x-axis. So these are all the lines in red color. Then we applied like the second transformation or the first transformation. We add up number 2 to the argument of the function, which basically means, as we already know, you take away number 2 from x coordinates of all the points that belong to the parent function. So basically this number 0 or x coordinate becomes -2, because we took 2 away from 0, and as you can see, this transformation doesn't impact our y coordinate, and also it doesn't impact our asymptote, so asymptote remains on the same place. Next transformation which we did, we just we can say we multiplied our function by -1, or we put the -1 in front of all the values from the previous function, which basically means that our y coordinate of the anchor point changed to the opposite number. But this transformation didn't impact our asymptote. So the main point for this transformation was this one. Asymptote remained the same. And the last transformation we did, we add up number 3 like to the whole function, or to all the values of from the previous function. So basically, as I denoted here, y values are increased by number 3, which means that our anchor point is traveling to the point with the coordinates, and I didn't write it here, but these are the coordinates -2 and 2. Okay, let me just show you one more tricky thing, maybe, so that you will realize how my anchor point traveled. So this is where my point started its journey, let's say. Then we moved it 2 units to the left. Then we flipped it over the x-axis, and the last transformation, it's hard to show it here, but my point was moved again 3 points up, so his journey ended here. and the only transformation of the asymptote was traveling 3 points up. So this is basically everything, and what I wanted to show you is the last thing. I already prepared the graph from the Desmos, and this is what you usually can check by your own. You try this exercise, and after that you write the equation of the function to the Desmos, and you will see, and you will get the graph like this, which basically corresponds with our graph, because as you can see, which color should I use? Yeah, let's use the yellow one. As you can see, the function in Desmos really passes through the point with the coordinates -2 and 2, so we are correct. And our asymptote, as it is not very clear, but I'm pretty sure you can find out that this really passes through the point 0, 3, or it never touches the line with defined by the equation y equals 3. Okay, so thanks for watching, and see you during our tomorrow's lesson. Bye bye.